So the global challenge really is energy supply, and I know I'm preaching to the choir here on this. Energy demand's going up, energy supply's going down. You guys remember when we were going to run out of IP4 internet addresses? It was about 15 years ago. We were going to run out. Anybody run an IPv6 in here? Oh, one person, okay. So we are moving IPv6, and IPv6 is going to give us a lot more address space. But why didn't we run out of IPv4 spaces? Well, the reason is we innovated. We were hit in the face with a problem that we had to solve really fast. And we started using NATing, network address translation, reusing addresses, which originally wasn't done. Everybody had their own address on, that created a whole host of other problems. It wasn't the best eloquent solution we had. But I just wanted to point out, as we move forward to energy demand and energy supplies, the one thing that's very hard to predict is the innovation around how we make these resources last longer, like IP4 internet addresses. So the energy expense is a very large unmanaged expense. Does anybody in here manage the expense of the energy for your organization? Like pay the power bill? Anybody in here pay the power bill? Yeah, you do? Do you pay for IT, are the IT folks in charge of that? Okay, and facilities, everything? Great. That's not the norm. And that's a big problem here. And that's why I wanted to point out that, when we can see if I can use this. There's the laser. Does that work? I told you I was a technology guy. Can't work the laser. Oh, there it goes. Look at that. All right. So on the IT energy use here, right, you've got, IT equipment, which is a lot of it, but, lighting, heating, cooling, and ventilation. You might even call this chart a PUE chart, power usage effectiveness, right? So power usage effectiveness really measures the amount of power going towards the overhead as well as all of the IT devices. Very common metric used in data centers. But the data center energy use, this is what the data center folks are really interested in. But anyone in charge of their IT groups? In charge of IT? So if something breaks, does your phone ring? My phone still rings. When I worked at NIST, I ran some of the data centers, some of the equipment there. I used to joke that my job was to prevent my phone from ringing. And why? Because I never got the phone call that said, Scott, thanks for the 5 nines reliability, that was awesome. But I did get the phone call that said, I can't get to the internet, or I can't access this, or my email is down. Those phone calls I did get. And that's one of the problems that we have with regards to energy management. IT folks are driven by 5 nines reliability until the data center runs out of power. You can't plug anything else in until something unplugs. And I've seen that in several data centers. And that's, again, where the prefaces comes to make change. So there's many unanswered questions about power in data centers or in environments. We know about meters, we've got a little meter here. And we're very, very used to seeing meters, and that's how we measure power, particularly at home, right? You get a power bill, which is based on this meter on the outside of your house. But it's very difficult to understand what did I pay for? Anybody have a smart tag for the toll road? That was great. Really convenient. How much are you paying for the toll? Did anybody manually pay a toll here on the way in? Anybody manually pay a toll? Do you know how much you paid? I have a smart tag. I have no idea how much I paid. I just went right through. But when you have to pay, you remember and you know, and it will change behavior. And so it's good to know, what are each of these individual devices running? What are these devices? What is it costing me to run those? Who's the top consumer? Again, that can help change behavior. So we get an electric bill every month. What did I pay for? I don't know. Where can I save the most? When you get home, do you leave your car running in the driveway? Anybody drive a hybrid? So that turns itself off, right? That is an 1800s electric car. It had a top speed of 20 miles per hour, and it would go about 50 miles. Not bad for late 1800s. So, what won out was convenience. right? What won out was the internal combustion engine. Interesting that we actually had this type of technology many, many, many years ago. But it has to be easy and it has to be motivating. This is where we get into trouble with the energy management challenge. When we're looking at energy management, it would be nice to know what the cost of every device that plugs in costs us to run and costs us to operate. But can you imagine if you had to meter every single device, every individual device? It's just too costly, you can't do it. So there's no single energy management system across domains, right? There's a lot of different ones. Maybe there's some for the distributed office network. And maybe we're doing PC power management. Well, what about the printers? What about the phones? What about the other devices? What about the lighting? What about, you know, the lava lamps? And I'll get to that in a minute. Data centers as well. I mean, you've got the overhead of the crack units and all of the other types of devices, power distribution units. Really, I care about the 5 nines reliability, which is driving these. And then, you know, the facilities, the overhead costs of the building themselves. Wouldn't it be nice to be able to see all of this in one place? What's driven some of these challenges here is really infrastructure. It's proprietary, it's aging, it's siloed, and I say it's status quo. There's no impetus to change. There's no reason to change. Why should I change if it's working? I'll give you a prime example. I'm guilty of it myself. I had bought a house built in 1970, and I hired an engineer to come out and check out, you know, the quality of the air conditioner and the quality of the heater and thing. And it had a gas furnace in it. The guy comes in and he looks at it and he goes, "I can't believe it." I go, "What?" He goes, "This gas heating system was built at the time the house was built, and it's working fine." Did I replace it? No. Should I have? You know, had I replaced it when I bought the house, I bet you I would have saved enough money in the efficiencies gained in 30 years of innovation. But I didn't because of status quo. It was working, it was good enough. So with cost, we also have increased use, more demands on that same proprietary aging siloed status quo infrastructure, rising prices, energy waste and growth. There's regulations, sustainability, no standards. Actually, when I worked at NIST, we used to say the wonderful thing about standards is there's so many to choose from. I mean, does that make any sense? I mean, don't we want standards so things interoperate and work together? And operations can be complex. No visibility, or I would even argue too much visibility. Look at how many consoles this one guy is looking at. And I guarantee he knows everything that's going on in all of those. You know, response, and then new technology. New technology is a great thing, but sometimes it's hard to embrace because, again, the status quo and the change required to do it. Necessity is a mother. Wait. No, that's not right. Necessity is the mother of invention. I thought I had that right. Anybody see the Day That Earth Stood Still? It's not a great movie, but there was an interesting quote there, and it's this: "You say we're on the brink of destruction, you're right, but it's only on the brink that people find the will to change." And that's one of the things I wanted to kind of base my topic about today, is that will to change because of the status quo. Yeah, it's good enough, it's working just fine. Only at the precipice do we evolve. So when I'm standing there looking over the cliff, I go, I think maybe there's something I need to do differently. And that's when we really start to make the changes.